Hi, and welcome to the in-person tour of the Kendeda building focused on materials, water, and energy, which are three of the petals involved in the Living Building Challenge. Today we're going to tour the building and we're going to focus on some of the design characteristics that were put in place to meet these particular criteria of water, materials, and energy. And really explore also through reflection how we use water, how we use energy, and how we think about materials and waste in our own lives. So we're starting in the front of the building, and we're here by the front door. The water and energy petals are really, really simple. So the Kendeda building was constructed to be net water positive and be net energy positive, which means that the building is regenerative. It will actually produce more electricity than is consumed, and it will capture more water than is used in the building. This seems like a simple premise, but of course a lot goes into that. And I just want to point out a few of the things that we can see at the front of the building. Number one, if you look up, you will see the solar panels. And the solar panels cover the entire building except for the rooftop area. And they even extend beyond the building to create a shaded porch. So all of these panels here run along the western side of the building and provide shade to the porch area. So this is the porch, and there are some rocking chairs and seating areas out here as well. And there are some doors along the side of the building that open as well. So it's a nice place to come sit, and it looks out over, you'll see this construction fence on the other side. Behind that construction fence is the new Eco Commons, which is going to be a beautiful green space with walking paths and reflection areas and all kinds of places to relax and recreate. Another thing I want to point out at the beginning of the building is this gravel pit that is planted with plants. This is actually not a planter. It is a constructed wetland, and it is functional because it filters and cleans the gray water that comes out of the building. If you're unfamiliar with the term gray water, it is used water, so it's not perfectly clean, but it doesn't contain like urine or feces, so that's called black water. That's the most difficult thing to clean up. But gray water can be cleaned up more easily, and that's the kind of wastewater that comes from your sink drains or your shower drains, or in a house. We don't have any dishwashers or washing machines in this building, but those kinds of drains would also will also produce gray water. And if you filter gray water through the ground, it cleans it up. And so the gray water in this building, all of the water that comes out of the drains, gets filtered through this constructed wetland, and you can actually even see. Let's see if I can show it to you. You can see this port. So that green manhole has you can open, and there are some students doing experiments on that water that is, and testing it for different levels of different kinds of contaminants, and seeing how well this wetland and these plants are cleaning up the water. After it filters through those plant roots, it actually drains all the way down through the ground, all the way down the hill, until it ultimately just joins the groundwater. Okay, let's see. Other things we can point out. Oh, the rainwater is collected off of the roof. So all of these solar panels, in addition to producing electricity, have gutters on them, and they capture the rainwater and filter it. I'll show you some of the pipes inside the building, but the water goes through these gutters and through some pipes and is collected in a giant cistern and is purified then for drinking water. So that's one way that we are working to achieve net positive water. There are also special toilets that I'll show you inside that deal with black water. And oh, there's also a really cool system in place for condensate. Okay, I'm gonna go inside now because it's loud out here because they are trimming some tree branches across the street, and we'll continue the tour inside. I'm right inside the front door now, and I wanted to point out this pipe. So if you look to your left, you will see this rainwater pipe. This is one of the pipes that is collecting the water from the roof and taking it down into the cistern. And if we walk down stairs, we'll be able to see some of the water systems that are on the ground floor. So now we're just gonna walk down there. I'm gonna walk down the ramp. There's our ramp. Looks like they're having class in the auditorium. Looks like there's 4 people in class today. All right, and we'll turn right here and go down the stairs. If you look straight ahead, you'll see a beautiful mural that explains all about the water. So this would be a great time to pause the video and take a look at this beautiful mural that's all about water. And then we'll come back together and I'll point out the water cisterns and some of the meters. So now that you've reflected a little bit about water and water usage, we're going to walk away from the mural and toward this caged area that contains a lot of the water systems. So if you take a look here, we've got this large black tank. This large black tank contains condensate water, and in this building that water is utilized for irrigation of plants on the roof and plants around the building. That's what this black tank is. Behind this concrete wall that's behind me is a giant cistern, and that's the cistern that contains the rainwater that is then purified for drinking water. If you keep moving over, you can see the meter for the drinking water. So it's in this gray box. There's a little digital display, and I'd like you to pause the video and make a note of how many gallons of water are currently in the drinking water cistern. Now we're going to move over here, and we're going to see some of the water filtration systems. So the drinking water is processed if it needs to be cleaned in any way in order to be safe to drink. Things can be added to it. So you'll see we've got a tank that contains a little bit of chlorine that can disinfect it. We've got a tank that contains some chemicals that will adjust the pH of the water. These tall stainless steel cylinders contain filtration that reduce, you'll see it says turbidity reduction filter. So that's going to reduce any particulate matter that is in the water. And then we've got a charged membrane filter next to it that's going to further purify that water. And then we've got another couple of other meters. So okay, if you keep rotating around, These are this is some of the HVAC system. So this has to do with the heating in the building, and we'll talk more about the heating when we talk about energy. These are heat pumps that can help augment the temperature in the building. And then there's, if you look through this glass door, you'll see there's also a testing center, a water testing center, where some of the water quality testing is done. So think about ways that you can reduce energy consumption and see if you can observe some of the more obvious ways that this building reduces energy consumption as you walk through it, and make a note of it. I'm going to point out some of the more hidden ways that this building reduces electricity usage as we go around the building. Before we keep moving around, though, I want you to look through this window here and take a look at these meters. One of the meters that I think is the most interesting to look at is the PV load and the total building load. So the PV load reflects how much electricity is being produced by PV, stands for photovoltaic. So this is the amount of electricity being produced by the solar panels on the roof. And it is a cloudy day, and so we're not producing much solar power. The easiest number for me to look at is that bottom number of the 3. That's the kilowatts. So right now on this meter it's saying 8.1, but it's cloudy. Maybe when you visit it will be sunny. So you want to take a note of how many kilowatts are being produced by the solar panels when you're here, and how much electricity is being used. That's the total building load there, which right now is 19.4. Again, it is a cloudy day, all the lights are on, and so right now the building is using more electricity than it's producing, but that's not always the case. Many times when I've come in the summer, it's been producing something like 10 times as much electricity as being consumed. For the Living Building Challenge, you don't have to always be producing more electricity than you're consuming, but over the course of a year, you need to produce more electricity than you consume. What you do with the surplus is sort of up to you. In some places, there are a lot of batteries, and I think at one point this building was going to have some storage batteries for the excess electricity, but they ultimately decided to send that electricity back into the grid. Down here is really fun. You can also press these buttons, these green buttons that are on the wall. Don't be afraid to press them. And if we walk over here a little bit to the right, we can press a light and look at another really cool thing down here. These are the composting toilets. So if you think about water usage, it's kind of ridiculous that in our country, we take potable drinking water, poop in it, and then flush that potable drinking water away. That's a huge waste of potential drinking water. This building is not even connected to the sewer. So the poop in this building does not wind up in the Atlanta sewer system. It winds up here in these composting toilets, which you can't even see through this window. This is this door here. We're at this building, this room, composters. And if you press this light, you'll be able to see the composters behind. And there are these big bins. The waste goes straight down into there, and they get mixed with some wood shavings. The liquid waste gets pumped out, and then all the human waste gets composted rather than flushed into the water system. Speaking of human waste, we're going to go upstairs now and explore your next project, which is to check out the composting toilets. Well, check out the non-flush toilets, the foam flushing toilets. So let's go back upstairs again. Here's the stairs. We're gonna head back upstairs. You can always use the elevator if you need to. Of course, it's right over there. I'm gonna go up these stairs. Looks like they're doing some painting or something here. But you have your choice of restrooms. We've got men's rooms, unisex restroom, and a ladies' room. Oh, that room is closed, so we'll go in the unisex. Here we go. So when you enter the bathrooms in this building, you trigger the automatic lights. The lights will turn on and the toilets will turn on. So these toilets do not flush. There's no water in them, but they do rinse the waste down with foam. So what you need to do is go into one of the bathrooms in the building and wait until the foam starts to fill the toilet and take a picture of the foam. It'll be exciting. This is part of your assignment. You'll also see there's a shower in the building. This was put in place so that anybody who bikes to work can take a shower there, bikes to work or school. And I'll point out some of the neat materials in this room just because we're not coming back. Part of the Living Building Challenge is to be very conscious of the materials that are used to build the building and to reduce the amount of new materials that are needed to build a building. Salvaged materials are used. So on this wall, these tiles, I'm trying to point to them, there we go, the gray ones, these tiles are made from slate that came from the roof of the alumni house when they re-roofed it. And so they collected all of those slate tiles from the roof and broke them up into pieces and used them to make this beautiful pattern and reduce the amount of new ceramic tile that they needed to produce this room. All right, we're gonna come back out of this bathroom now. And we'll head upstairs and talk about some of the other energy saving methods. So make your way up to the 3rd floor. All right, I'm on the 3rd floor at the top of the stairs, standing by this interesting display that describes the red list. The red list is a list of materials, toxic materials, that are prohibited from being used in living buildings. I'm gonna sit in this chair. So some of those toxic materials include things like cadmium, chromium, lead, mercury, polyvinyl chloride, PVC. So they had to use different types of pipes in this building, as well as certain types of pressure-treated wood products. So you'll see a lot of wood in the building, but the types of pressure-treated wood that are used for exterior woods are not used in this building. And the exterior wood that you'll see on the outside of the building is acetylated rather than being pressure treated. It's basically pickled wood. And a lot of the other wood in the building has been salvaged and reused from other places, including from the very site that this building is built on. So I'm sitting at this counter here, and this counter is made of, it's from milled wood from a felled tree that was taken down during the construction process. So the tree was sawn, and you'll see a few of these counters around the building, and they're beautiful. They have a live edge, so you can really sort of see that, that connection to nature, connection to the site. In the last video, we talked about these wood panels that make up the decking in the building. And these wood panels are half salvaged. So they're made of 2x4s and 2x6s that are nailed together. And all the 2x4s were collected from the Life Cycle Building Center. And many of them had been used on movie sets in the Atlanta area before they were built, nailed together and used in this construction process. So about half of that material is salvaged. While we're looking up that way, you'll see all those pipes, all those silver pipes. Those are the pipes that provide, they circulate water through the concrete floors. There's concrete poured on the top of this decking, and the floors, the temperature is regulated in the building by the temperature of the water in those pipes. Also, while we're looking up here, let's see if I'll rotate this a little bit, and you can see the fan. Maybe, where's the fan? There it is. So we've got fans in almost all of the rooms, these ceiling fans. Some of them are very large, some of them are smaller, but air circulation, of course, makes you feel cooler. And so in the summertime, this building does not require air conditioning, and that saves a lot of electricity. Another thing that makes you feel cooler in the summer is to have dry air. You know how people say in the desert, there's this dry heat and you don't feel as hot? Well, that is true. And so if you have dehumidified air, you feel cooler. And while this building does not have air conditioning, doesn't cool the air, it does reduce the humidity in the air. And the system that does that is out on the roof. You can actually see it out this window. If you look at that silver mushroom looking thing out there, that is the dedicated outdoor air system, or DOAS, that removes the humidity, and that moisture is captured in the condensate tank that we saw in the basement. So that's pretty cool. Other things that we can look at here in terms of salvage materials, that wall behind me is entirely salvaged wood. The treads on the stairs are salvaged wood treads. A lot of this wood was collected in renovation of Tech Tower. So I believe that's where all of that wood came from. When they renovated Tech Tower, they saved the wood and used it in this particular project. The last thing I want to point out on this tour is waste. So you see this large container behind me. We're still on the 3rd floor, but these are on every floor. And there are different diversion bins for different types of materials to reduce the amount of waste going to the landfill in this building. One of the imperatives for the Living Building Challenge in the Materials Petal has to do with waste. And the statement for that particular imperative states, this project must reduce environmental burdens from the extraction, processing, and disposal of materials and turn waste into a valuable resource through beneficial reuse. The project team must strive to reduce or eliminate the production of waste during the design, construction, operation, and end of life in order to conserve natural resources. The most visible part of this process has to do with the operation phase. So when we look at these recycling bins, we're thinking about the operation phase of this building. But as this building was being built, all of the salvaged materials that were being used reduced the waste. That would have been a product that would have wound up probably in a landfill or composted rather than being reused. And even end of life. So as this building was constructed, the contractors and the engineers and the architects that designed and built this building considered all of the materials in the building and whether they could be recycled later or reused in some kind of way as they were selecting those materials. Great, so that concludes our tour focused on energy, water, and materials. And we'll do one more tour later in the semester focused on health and happiness, beauty, and place. Bye.